Okay, we're in the examples, and we're going to go through the examples. This is a review, and again, it's a review for the students that are in my class of Math 121 at Essex County College. So let me get my highlighter out, or my pen out exactly. Let me see if I get it working. And we'll go through, I don't know if we'll do every problem, but certainly most of this stuff here should just be a very simple review for you. When I say that, some of the problems may be more involved than the others. Now, of course, number one is a Math 100 review problem. It wants me to find the equation of the circle, and certainly they give me the equation of the circle. They want to put it in standard form and get the center and radius from it. Let's do this for you. What do you get? X squared, and then you can get minus 6x. I'm collecting the x's together, and then the y's, y squared plus 10y, and I can put the constant on the other side. And the form we're trying to get is this over here, x minus h squared plus y minus k squared equals r squared. But you understand, once I get in this form over here, the center is really easy to write down. The center is just h comma k, and the radius is equal to r. All right, we're almost there. I'm going to do complete and square. Half of minus 6 is minus 3 squared. You get plus 9. So I'll add 9 to both sides of the equation. And half of 10 is 5, and that squared is 25. And I'll add 25 to both sides of the equation. And what do you get? X minus 3 squared plus y plus 5 squared equals 25. So the center, very simply, is going to be 3 comma minus 5, and the radius is 5. These answers are listed for you, and they're listed for a reason. We want you to check them. All right, this one over here, they want me to calculate this thing without using a calculator, and this is a log base 2 problem, all right? So what I'm going to do is I'll write the 8 as a base 2, and I'll do that pretty simply. This is going to be log base 2, and 8 as a base 2 would be 2 cubed. Well, it's going to be 2 cubed to the second power. Now, what does that give me? Let me write this down for you. It gives you log base 2 of 2 to the 6th power. Well, this will just be equal to simply 6. Again, logs were covered in Math 119. So number 1 is Math 100. Number 2 is Math 119. Now, when I say that, if you need to review logs, go back to the 119 notes and review logs. All right? Answers are provided for a reason, by the way. This one says evaluate without using a calculator. This is Math 120 now. All right, looking at this one over here, I want to point out the way I teach it may be different than the way your teachers teach it, but the answers are not going to change. The invertible region of the tangent function is this region over here, which goes between minus pi over 2 and pi over 2. And I'm looking for the ratio of 1. And when would that occur? At 45 degrees. We don't like to speak in degrees, although it's very convenient for us. I want to put the radian measure down for that, which is pi over 4. All right, this one says show, blah, blah, blah. Show that this and that are rational functions by writing each as a quotient of polynomials. Well, a rational function is a ratio of 2 polynomials. Let's do this, see what we get. What's f of x? Oh, by the way, this is Math 100 and Math 119. All right? So what do you get? X squared plus 3 over x. And I'm going to write that as a single fraction, and that would be x, which would be x cubed plus 3. All right, that answer is right over there. We wrote it as a ratio of 2 polynomials. Now let's do g. And what's g going to be? Well, 5x cubed minus 4x plus 1 over x squared. I'm going to write this as a ratio. That's x squared, 5x5 minus 4x cubed plus 1. All right, that's right over here. All right, let's look at this one over here. And they're a little more complicated, I'll be honest with you. This is Math 120. Now, that's the most recent course you've taken prior to Math 121. But again, you may be confused by this. It says simplify by referring to the appropriate triangle or the trigonometric identity. And I want to point out that it's a little tricky, though. When I'm doing this over here, I'm going to, talk about the invertible region of the cosine function. And the cosine function, the invertible region here, I'm sorry. I misdrew there. I got to erase this now. I'm sorry about that. The invertible region of the I keep saying this. I'm not looking at the tangent function. I'm looking at the cosine function. And the cosine function looks like this over here. All right, so that's the invertible region of it. And that's between 0 and pi. And what do I know about the tangent function for this over here? Now, if I looked at the tangent function would look like this over here. All right, so I know that much. All right, so I'm hoping you get an idea over there. And what do I know about the tangent function once you get this side over here? It would look like this over here. All right? All right, so I sort of like, I know what the tangent function looks like. I know what the cosine function looks like. And what's nice about this over here, and maybe I've given a little bit too much thought, by the way, that I want to point out what I'm looking at. I'm looking at this region over here. And what do I notice about the sine, when I say sine, S-I-G-N, of both the tangent and cosine are identical in that region between 0 and pi over 2. And then when I know about the cosine function, the sine of it's identical between pi over 2 and pi. So I have no worries now. So I'm going to start to erase this business over here. And I'm going to do what they suggested, which is the right triangle. And I'll put this one down for you. And a right triangle looks like this. And I'm going to say the angle theta. And I'll put the ratio down. Well, the cosine of that angle theta, and this is the angle theta over here, is going to be x and 1. And this side over here, I guess I got to use the Pythagorean theorem, right? And that's the right triangle, by the way. And it's the root of 1 minus x squared. Now, what's the tangent of that? I'll write that down for you. Let me erase this over here. The tangent of that angle theta is going to be, I'm looking at it, the root of 1 minus x squared over x. All right, and we're done. All right, look at the key. And they say this is valid for all numbers between minus 1 and 1, but it's not valid at 0. All right, not valid at 0. All right, let me take a look. Let me keep going. And let me see if I can do that. This one says find the roots of the quadratic polynomial. Well, that's easy. How would you do that? This is really a Math 100 question. But roots were covered in Math 119. But certainly in Math 100 they talked about the roots. They actually used the word of a quadratic. And let's write this down for you now. So it's going to be equal to 0. That's what the roots mean, are the zeros. So roots are also called zeros. And let's do that. And how do I do that? Well, I'm looking at it. I'm going to just go right in with the quadratic formula. The bottom would be twice a, which is 12. And the top would be what? Opposite of b, which is 7, plus or minus. We have an answer key to look at, by the way. And if I make a mistake, I'll certainly rectify it. The b squared is 49. Minus 4. And what's the a? The a is 6. And what's the c? The c is actually minus 5. So I'm just going to simplify that by putting that over there. I want to go through the work with you. 12 on the bottom still. You get 7, plus or minus. And I'm expecting to see 2 roots, guaranteed. All right? So what do you get? Let's see. You get 49 plus you're going to get 120, right? And what's that going to be? 169. Well, that's convenient, isn't it? So 169. Now, why is it convenient? I could have factored the problem. Why did I do the quadratic? I didn't get tired, maybe. 7 plus or minus 13 over 12. And I can do that. 7 plus 13 is 20. So it's 20 over 12. Or it would be 7 minus 13, which is minus 6 over 12. Now, what are the answers? I'll write them down for you. And I'm going to simplify it by reducing them. That would be what? I'm going to do it by 4. So 5/3 or minus 1/2. They are the zeros of that polynomial. So let's just make sure we did that. Now, of course, when I did it over here, I did it by factorization, which is probably something that might be a little quicker than using a quadratic formula. Does it lead to the same answer? Of course it does, as would completing the squares. This one says complete the square. This was covered in Math 100. Well, I'm going to complete the square on it. What do you get? X squared plus 4x. Let's see. How would you complete the square? Half of 4 is 2. I'd add 4. But if I add 4, I'd have to subtract 4, and there's still a 1 at the end of it. And what do you get over here? You would get x plus 2 squared minus 3. Now, by the way, they did say complete and square, but they said something else. They said, find the minimum or maximum value of the quadratic. And what does that mean? This is a quadratic function, and it's a parabola. The minimum value would be here. And this is a convenient form for the vertex, by the way. So the vertex occurs at the number minus 2, comma, minus 3. So what's the minimum value? The minimum value is minus 3. All right, where does it occur? It occurs at minus 2. So let me just make sure. So it says minimum value occurs at minus 2, and the minimum value is minus 3. And I did that by completing the square, which is not a bad way of doing it, by the way. All right, not a bad way of doing it. All right, this one says find the slope, y-intercept, x-intercept of the line of a given equation. Fairly simple. Let me write this down for you. The slope, and this is written as y equals mx plus b is 6. What's the y-intercept? I'll write this one down for you. And again, this is math 100 now. And y-intercept is going to be when x is 0. Well, the y would be 12. And now let me put down the x-intercept. Relatively simple. What do? I set y to be 0. And if y is 0, what would you get? X would be minus 2. Let's check our key. We got the 6, 0, 12. Whoops, made a mistake. I do that sometimes. I'm going to have to correct myself, don't I? So let's go back over here. And I want to emphasize it's a really good idea to read an answer key. Because if you read a mistake that you say, oh, gee, I don't want to do that again. And that's going to be minus 2. Sorry about that. 0. And I see that. I made a mistake. All right? This one says use an augmented matrix and elementary row operations. This is math 119 now. Okay, let's write the augmented matrix down, which is relatively simple to do. 2, 3, 2, 3, minus 3, 4, minus 1, 1, and 1. I'm going to put a solid line there. Some of your teachers put a dashed line down. It really doesn't matter. Both are acceptable. Minus 7, 12, and minus 3. Now, again, we're not learning. We're reviewing. So what am I going to do? I'm going to probably do this. I'm going to take row 1 and add it to row 2. And I'm going to give it to row 2. And I'm going to take row 1. I'm going to add it to row 3. And I'm going to give it to row 3. All right, now what does that look like? If I did that, this matrix here is going to look like this one. 2, 3, minus 1, minus 7. I did nothing to row 1. But what did I do to row 2? I added row 1 to it. And what do you get? 5. 0. Wow, that's convenient. 0. Wow, that's convenient. And what do you get over there? Well, 12 minus 7 is 5. And this is pretty nice, by the way. What do you get now? Well, row 1 plus row 3 is 4. 7. 0. That's convenient. And what do you get? You get minus 10. Now, what I mean by that, I'm really done with my row operations because I can start to read this. And I want to point out what I mean by that. The second row is very readable to me. What does it say? It actually says 5x is equal to 5. And I know by looking at that x is now equal to 1. And now what I'm going to do, I'm going to look at this row here, and I'm going to try to figure out what that says. And what does it say? That says 4x plus 7y is equal to minus 10. Now, if x is 1, that would be 4 plus 7y equals minus 10. Relatively simple equation. And what do you get? That would give you 7y equals minus 14. Wow, this is very convenient, isn't it? And y would equal minus 2. So I know what x is, I know what y is, but I don't know what z is. So what I'm going to do now is I'm going to take the first equation and try to figure out what z is. What does it give me? It gives me 2x plus 3y minus z equals minus 7. Well, I believe x is 1, this is 2. I believe y is minus 2, that's minus 6. Minus z equals minus 7. This is minus 4 minus z equals minus 7. Now, some students can look at that and answer it. I'm just going to go through the work. Minus z, I'm going to add 4 to both sides, is going to equal to, what would that be? That would be minus 3, so z would equal 3. All right, I want to just go through this, make sure this has been answered for me. And what did they say? X is 1. I got that part. They said y is minus 2. I got that correct. And they said z is 3. And that's right over here. All right? All right, let's determine the domain of the function. A little tricky, isn't it? So let's write this one down for you. What do you get? Well, this is x plus 1 over x, and this is x minus 3, and x plus 8. If you want, you can simplify this further, but there's no need to. But I just want to point out some students will do that by multiplying the top and bottom by x. Or they get x squared plus 1, x minus 3, x plus 8. So what's the domain of this over here? The domain is all real numbers. That's called the blackboard R. There's nothing wrong with writing that down. And then what do they say? You know, what numbers are excluded? Well, x can't be 0. I would be divided by 0. I see that here. And I see that here. The other numbers it can't be 3, and it can't be minus 8. And let me write those down for you. So it cannot be 3. That would be a division by 0. And it can't be minus 8. Let's look at the k, and they list those numbers in order, minus 8, 0, and 3. All right, they say find b, so the point, that point, that point, and that point are on the line. If they're on the line, they have the same slope. The slope is an invariant if it's on the line. So let's write this down. Let's put the slope formula down. So what's m going to be? Well, I'm going to take the first 2 points, and what do you get over there? Well, 3 minus a minus 3, which is plus 3. That's a change in y. And then it would be 6 minus 5. And what does that give me? That gives me 6 over 1. So the slope is 6. Now you could take any other 2 points that you want. And I'm going to take, I don't know, I guess I'll take these 2 here. And that slope also has to be 6. And what would that give me? Well, the change in y, 9 minus 3 over the change in the x's, which is going to be b minus 6. So 6 would equal 9 minus 3, which is going to be 6, and then b minus 6. I need to solve this equation now. And what do you get? You get 6b minus 36 equals 6. Wow, a lot of 6's here, aren't there? I'm going to divide by 6. You get b minus 6 equals 1, or b equals, by adding 6 to both sides, 7. All right? Looking good. Again, fairly simple questions, by the way. Oh, by the way, let me just remind you what this is Math 100. Number 10 is Math 100, and it's Math 119. And there's a lot of overlap in our courses at Essex County College, right? Math 119. A tremendous overlap, by the way. And that's going to stop in the future, hopefully, for you. So it says find the numerical coefficient of the term x6, y cubed in the expansion, and this is Math 120. So I'm looking at it, and this is an expansion, by the way, and it's going to have 10 terms in it, but only one of the terms would have this in it. And what would that term be? I'll write down for you. There's going to be some term, dot, dot, dot. There's some term that's going to have x to the 6 in it and y cubed in it. And I got to look at that. And I'm looking at what term would do that for me. And let me write this down for you. I'm going to erase this over here. And I know there's going to be a term there like that. And it's going to look like this. It's going to look like x raised to the 6th power. This is the binomial theorem, by the way. And then minus 2y cubed. And then your teachers told you about these coefficients, and there's many ways to generate them, including using a Pascal triangle. I don't think a Pascal triangle is good for a 9, though. So I'll write this one down, and it's going to be 9. You could either put 6 or 3 down, because if you choose 6 or choose 3, it doesn't much matter. It's the same thing. And now I got to compute this guy. Now someone says, you're going to really compute that? Yeah. But I'll be honest with you, get really exhausted, you can't compute them. Just put a box on it and move on. But I'm ready to do it, by the way. So 9 factorial, 3 factorial, 6 factorial, x to the 6. Now when you cube minus 2, that's going to be minus 8. I'll write that down for you. And then what do you get? You get y cubed. Well, I got some arithmetic to do now, don't I? Let's write this down for you. And what do you get? 9 times 8 times 7 times 6 factorial. I'm going to put the minus 8 in the beginning now. I'm just doing the number part. And at the bottom, what do you get? Well, you get 6 factorial, and 3 factorial is 3 times 2 times 1. And then what do you get? x6, y cubed. Again, I'm just computing this term over here. So all I'm doing. What's nice about this over here, there's some cancellations happening here. So this cancels off. And, I'm looking at it. I'm going to say 2 goes into 8 4 times. That's not so bad. And 3 goes into 9 3 times, all right? So what are you left off with? Minus 8 times, well, 3 times 4 is 12, right? And then you get a 7, x6, y cubed. I hate to bore you with the details, but you're expected to multiply that out. So minus 8 times 12 is going to be minus 80 and 16, minus 96 times 7, x6, y cubed. Calculator should not be used, by the way, but if you can't do a computation, you shouldn't be doing the computation. And what's that going to give you? Well, let's see, 7 times 9, right? That's 630 now. And then 7 times 6, well, let's see, that's 42, isn't it? So what do you get over here? Let me just do that in my head. That's going to be 672. Let me get my eraser out. And I'll check the key now. Let's take a look. And I got it right over here. Minus 672 x6 y cubed. All right, this one over here, convert to radian measure. It just couldn't get it any easier than this. Now, some students say they can do this without writing it down. We're not opposed to that. But the conversion factor is pi over 180 degrees. And what do you get? Pi over 3. Relatively simple. Kind of a gift question. What's this going to be? Pi over 180 degrees. No, you don't need to write that down, but it's nice if you can. Pi over 2. Now, 50 degrees is a little more challenging for me. Pi over 180 degrees. What do I get there? I get 5 pi over 18. All right? Looking good. So far, looking good. All right, find 2 coterminal angles in radian measure, one positive, one negative. This is pretty easy, because all you have to do. Oh, by the way, let me remind you, this is Math 120. This is also Math 120. So how do you do a coterminal? Well, basically all you do is pi over 3 plus some multiple, an integer multiple of 2 pi. And you could choose k to be any number as long as it's an integer. For example, if you chose 0, you get pi over 3, but I don't want that. I want some new ones. So let's use 1. But before I do that, I want to write this so it's easier for me to do the arithmetic. And what's that's going to be? Well, it's going to be 6 pi over 3 times k. So if I chose k to be 1, what would I get? I would get 7 pi over 3. If I chose k to be 2, what would I get? Well, you'd get what? 13 pi over 3. All right? So I'm going to say that's pretty simple. I got as many as I like. Well, I also want to get a negative one. So let's do k equals minus 1. And you could do as many as you like, by the way. You could do minus 2 as well. So let's do, k. And again, I'll answer that question in a second. If k is minus 1, what do you get? Minus 5 pi over 3. Now, if you did k as minus 2, what would you get? Minus 12 plus 1, which is minus 11 pi over 3. What would they say? 2 coterminals, one positive. I'll choose this one because it's small, and one negative because that's small as well. These answers are being listed for me right over here. All right, this one says solve for x on the interval between 0 and 2 pi. So I'm kind of looking at it. I'm going to, the method that I teach my 120 students, your method may be different because you have a different teacher maybe, but your answers are not going to be any different. I'm going to go through it for you, and what I'm going to do is I'm going to try to isolate the sign together. So I'm seeing root 2 is equal to 2. I'm sorry, I'm going a little bit too quickly. I shouldn't do that. Let's see. I'm going to say 2 sine x is equal minus root 2. Sorry about that. And then what I get sine x equals minus root 2 over 2. Now that looks really strange to me. By the way, it may not look strange to you because your teachers may have forced you to write that way, but I would have written this down as minus 1 over root 2. And I'm recognizing these two numbers, by the way. They're the same number. And what do I recognize? I recognize what's called a reference angle. So I'm going to put x sub r is a reference angle. And that reference angle for 1 over root 2 is 45 degrees. Or you can put down pi over 4. All right? I do want to answer the question in radian because they're actually speaking in radian. You should speak in radian. So I'm going to, put my, sorry about that. I'm going to put my sine function down, and I'm going to look for those areas of the sine function where I get a ratio of minus, and that's going to be in this area over here, which means it's between, let's see, 180 degrees and 270 degrees. That's one of them, and the other one's going to be between 270 and 360 degrees. But they have reference of 45, so between 180 and 270, that'll be 225 degrees. Now, if I did the other one, between 270 and 360, that would be 315 degrees. I want to write it down with radians though, and what's it going to be? 5 pi over 4, and the other one's going to be 7 pi over 4. All right, let's look at our case, see how we did it. I got this one over here and this one over here. All right, let's look at the next one. And again, it's a problem, they really kind of almost the same problem, but this is quadratic in form. So I'm going to factor it, and if you factor this thing over here, I'm going to use the zero product rule. What do you get? You get 2 sine x. Generally speaking, these will be simple to do because they're written to be simple. Sine x, that's equal to 0, 1 and 1. And let's see, I'm going to say minus plus. Let me just check it. What do you get? You definitely get 2 sine squared. That's good. Minus 2 plus 1 is, that's minus sine, and you do get minus 1. I'm using the zero product rule, which means sine x must equal minus 1/2, or sine x equals 1. And again, the way I teach it to my students might be different than the way your teacher taught it to you, or the way maybe you read in a textbook somewhere. But I always draw the picture, and the picture for sine function looks like this, and it equals, I'm sorry, I went too quick with that. I wasn't thinking what that said. The sine function looks like this, and it equals 1 there, so I definitely know one answer already. And what's that going to be? Pi over 2. Again, this is still Math 120. It's a prerequisite for the course, by the way. Now, minus 1/2, I think we just did that, didn't we? It's right over there. No, I'm sorry, I didn't do that. I was the minus 1 over root 2. And that's a problem. I think I've done something before, but it really was a different problem, but very similar. What do I know about this? A reference triangle, and I'll put down the x to reference, xr, and that's going to be a reference of, you see, 1/2. And what would do that for me? Well, let's see. For 1/2, that would be 30 degrees, right? And what's 30 degrees? It's pi over 6. But here's the deal. What quadrant it's in? It's in the quadrants over here, which is between 180 and 270 and 270 and 360. So I'm going to say 210 degrees, which is the same thing as 7 pi over 6. And the other one's going to be 330 degrees, which is going to be 11 pi over 6. So I'm going to say these are my answers, and I'm going to check the key. And what's the key say? Well, I see it here, 7 pi over 6. I see it there, 11 pi over 6, and pi over 2. This one says use long division to find the quotient and remainder when you divide. All right? So I don't know if I'm going to do every problem in this set, because it's a lot of problems, by the way. And I realize a lot of students, they say, well, how much do I need to do? You actually need to do more work than I do. And that's what a lot of students are not catching on to. And I want to point out it's really important you start to do work. All right? But x minus 2. And by the way, this is Math 119 and Math 100. All right? Let me write this down for you. And what do you get? x4 minus 4x squared plus 2x plus 5. I'm going to do the division. What do you get over there? Let's see. You get x squared. Let's see if I wrote that down right. Yep, I'll put it down. X squared. What do you get over there? X cubed. I'm sorry about that. You would get x4 minus 2x cubed. I'm going to do subtraction. You get 2x cubed minus 4x squared plus 2x plus 5. If you make a mistake, you'll know that by looking at the answer key. What am I doing now? I'm going to put down plus 2x squared. What do you get there? You're going to get 2x cubed minus 4x squared, right? Wow, that's convenient. What do I get? 2x plus 5. Let's repeat. Plus 2. We'll check the key later. 2x minus 4. The remainder now is 9. So what do I got? I know what the answer is going to be. I'll write this down for you now. I found by long division that I got a remainder of 9. I see that right here. And I got the quotient of x cubed plus 2x squared plus 2. All right? Let's take a look at the next one. And the next one says, find the angle theta in degrees between 0 degrees and 90 degrees. And this is the cotangent. And certainly I'm going to just do a right triangle for you. Why do I do that? It's between 0 and 90, so I can do that. I'm not saying it's terribly accurate, but I'm going to say this is theta. And the tangent would be root 3 over 1. So root 3 over 1. And what goes over here, 2? You should recognize that triangle as being a 60-degree angle now. right over there, all right? They also said radian measure. Let me write that down for you. That would be pi over 180 degrees, and that would be pi over 3 now. And that's written right over here for you. Well, let's do the next one, the domain of this one over here. Again, that's a Math 119 question. Now, the one concern a lot of students have is saying, how much do I need to remember from the prior courses? As much as you possibly can. As you move forward, the more you can retain, the better your educations will become, and the more confident you'll be get when you take more advanced courses. All right, let's put this down. So 2x squared. This is the radicand. What do I know about it? The radicand can't be 0 because it would be division by 0. But more importantly, the radicand must be greater than 0. It can't be negative in a real number system. I'm going to try to solve that by dividing both sides by 2. I get x squared minus 9 is greater than 0. And I want to point out the way your teachers taught it to you, at least I hope they did, they taught it by sign analysis. And that's a really important subject area. Plus, minus. They put a number line down. They put the zeros down. That would be minus 3 and 3. And they did some testing with you, all right? Again, this is Math 119. It's really important you know that subject area. Now, if you took a number after 3, like 10, and you plugged it in, it would definitely be positive. So I'll shade that in. That's what we want. And if I took a number below minus 3, like minus 10, plugged it in, it would also be positive. Now, if you took a number between minus 3 and 3 and plugged it in, like for example 0, it would be negative, and I would not shade that in. So the domain of this interval notation is minus infinity up to minus 3, union 3 to infinity. I'm going to look at the K, and there is some work down over here, but they do list the answer for me. Now this one over here is a Math 119 question. And what's a Math 119 question? Well, it's asking about the inverse of that. So the one thing I want to point out to you, it's, at least I hope your teachers, when they taught this to you, that it's good to have a visual understanding of what they're asking for. So number 19, sorry about that. I jumped the gun on that. So what do you get over here? Let's write this down. I'm going to get a visual on it. And, you know, looking at it, I'm going to graph f of x for you. And what does f of x look like? It looks like, you know, at minus 3, that's where I'd have a 0. And then it looks like a parabola that opens upward like this over here. Now, when I do that over there, I got to get my eraser out because they say the x is greater than or equal to minus 3. And that's really important you understand what I just said there. I'm going to erase this over here, and I'll erase this too, by the way. I don't need that anymore. All right? So that's what f looks like. I'll write this down. This is what f looks like. Now, I kind of know what the inverse looks like, and I'll point out what I mean by that. This point over here is going to be minus 3 comma 0. And this point over here, I'm not saying I'm doing a great job of graphing it, is going to be 0 comma 9. Now, what do you get over here? Well, the inverse would be, you know, putting this point over here would be 0 minus 3. And then you got the, and again, I know my scale's not great over here. It should be better than what I'm doing over here, 9, 0. Right? So it looks sort of like this over here. Pictures are not necessary, and this is the inverse function. All right? Let's go through it, though. What do you get? You write y equals x plus 3 squared. Change x and y. X equals, and this is a technique that you were taught in Math 119, y plus 3 squared. What do you get over here? It's more complicated now. And what are you going to get? You're going to get plus or minus the root of x. And then what do you get? You get y plus 3. And we're solving for y. What do you get over here? You would get minus 3 plus or minus the square root of x is equal to y. And this is where the conundrum lies. I got to write down the right answer. All right? So before I do that, though, I want to write down the domain of this guy over here. What's the domain of this guy over here? It's going to be from minus 3 up to infinity. And the range of this guy is going to be 0 to infinity. And I get that by looking at the picture. Now, I'm going to write the inverse down. And I'm going to put the domain down for it. And how do I do that? I just look up here at the range. So the domain of this guy over here, quite simply, is going to be 0 to infinity. And the range of this guy, let me write this down for you. The range is going to be, let's see, from minus 3 up to infinity. Now, a lot of students question, is that important to know that? It certainly is. Because it's going to allow me to take this thing here and write the correct answer down. What's it going to be? Minus 3 plus root x. And why is that? It's got to be greater than minus 3. And that's going to give that to that over there, or equal to it. So this is the inverse. That's written right over here. and we got the domain down, and we have the range down as well, and it helped me with the problem. Number 20, this is math 120, and these are factorials. It's complicated though, and a lot of people are confused by factorial. Let me write this down. The top is 2n plus 2 times 2n plus 1 times 2n factorial. What goes on bottom? 2n factorial. What's nice about this? It does simplify nicely. What he left off with? 2n plus 2 times 2n plus 1. If you want, you can multiply it out, but it's not necessary. This is the correct answer over here. If you did multiply it out, what would you get? 4n squared plus 2n plus 4n plus 2, which gives you 4n squared plus 6n, whoops, sorry about that, plus 6n plus 2, which is that written over there. So I think that's enough for now. I'll come back and I'll finish. I'd also recommend that when you're doing study, and you should be putting in roughly about 10 hours per week of study time for this class alone, by the way. What does that mean? After you spend 4 hours in the classroom, you're expected to spend at least 10 hours outside the classroom study time. Right now, I realize that some students say that must be a joke. I never heard of something like that they're looking forward to a life where they don't work so hard. I want to point out, if you don't study, your life is going to be nothing but working. I mean, nothing but working. And by the way, in bone-crushing type jobs, by the way. I mean, jobs that just zap you of your soul. So I'm going to say over here, an education does have value. And I hope the value it gives you is options in the job market. It takes time and effort, though. All right, we'll come back and we'll finish a little later.